Imagine a perfectly executed demonstration. The AI model receives a prompt, crunches the data, and delivers a flawless output. No latency, no missing inputs, just pure, frictionless performance. Seeing this, it is easy to assume the work is done. If the model is intelligent and the test succeeded, it feels like the operational problem is solved. Fast forward 6 months into normal operations, and that friction returns. Inputs arrive late or in the wrong format. Business definitions drift. The primary reviewer leaves the company, or the underlying model receives a silent update that alters its baseline behavior. These breakdowns reveal that while the model's intelligence exists, it hasn't been operationally preserved to survive the changing environment. A successful episode only proves that a capability is possible. Protecting that capability so it can repeat, survive, and improve requires a governed workflow. Organizations extract lasting value when good judgment can return, be applied again, be transferred to new personnel, and be rigorously inspected over time. When a process collapses the moment a variable changes, the system lacks operational continuity. Without that continuity, an organization possesses only a collection of temporary performances rather than stable intelligence. Traditional workflows are static, linear flowcharts of boxes and arrows. Plugging autonomous AI into this rigid framework is risky. If assumptions drift, automation carries errors farther and faster. It generates reports without nearing a valid target state. This is mere motion, not effective progress. Effective governance treats a workflow as a system of state transitions, where each step is required to demonstrably change a variable, like reducing uncertainty, activating a constraint, or reallocating authority. This requirement ensures that every action produces a structural change relative to the objective, preventing raw activity from masquerading as progress. Operating a governed system requires specific mechanics. First, context must act as an active constraint. Instead of passive background text, it must be capable of blocking or redirecting a model if it attempts an invalid action. Second, authority must be dynamic. Decision power should shift among humans, models, and tools based on the strength of the evidence and the severity of the consequences. We must differentiate fixing an output from fixing the process. Editing a typo is a temporary correction. Structural repair changes the workflow to prevent recurrence. That repair becomes the system's memory, actively shaping future choices by excluding invalid paths. This creates a living workflow that uses its history to navigate, dynamically adjusts who is authorized to act, and constantly repairs its own structure. A mature workflow maintains its integrity through personnel turnover, tool substitutions, and data drift. While an AI model only owns its internal parameters, an organization requires a structure that outlasts any single piece of software or specific model version. This structure builds institutional intelligence, the guarantee that effective judgment remains available even if the original builder leaves or the specific model is retired. To achieve this, episodic AI capabilities must be structurally converted into repeatable and accountable organizational practices. Building this architecture transforms fleeting performances into a permanent organizational capability, ensuring that intelligence survives the reality of operations.